Afternoon, everybody. Is it working? Yeah. All right. So good afternoon, everybody, and welcome to our afternoon session with the original equipment manufacturers. I'll wait just a second for the conversations to finish dying down before kicking into my opening remarks. Okay, there we go. So once again, good afternoon, everybody, and welcome to our panel with the original equipment manufacturers. I just really can't stress enough just how important OEMs are to achieving our demand flexibility goals, right? At the end of the day, their products are really the ones that are shifting load. And so any goals that we have around load flexibility and any control strategies that we have around load flexibility have to work with the capabilities that their products are providing and have to be really created in collaboration with them so that we can figure out, what control strategies and what communication capabilities will help achieve both of our goals. At the same time, ultimately, equipment manufacturers are responsible for giving their consumers a product that meets their expectations. And demand flexibility in their world is kind of a bonus, right? And so we need to really keep that in mind as we work through all of this. Since we're running a few minutes late, I'll really keep my opening remarks quite short and largely just leave it there. So we're going to pass it over to them, and then we're going to talk some about how we can really balance these competing interests and balance all of our goals and collaborate to help bring about a flexible grid that also, probably more importantly, meets their customers' expectations. So with that, I would like to pass it off to them to introduce themselves and tell a little bit about their companies and their products. And we will start with Albert Rooks from Small Planet Supply. So next slide, please, Scott, and take it away, Albert.
Great. Thank you very much, Peter. Thank you for hosting me here today. Very excited to be here. I only have 3 slides and I promptly forgot them, so I'll be twisting my neck to see what they say. Small Planet Supply started a division to make central heat pump water heaters for multifamily buildings. We work with buildings from very small to reasonably large. And because it's a central system and it's a high value asset, we're actually able to put a lot of connectivity and a lot of features into the equipment. So next slide. Great. So along with the central heat pump water heater, the heat pumps and the controls and all that, we wound up designing a custom line of tanks to capture different temperature points across the thermal wells across tanks. We're looking at a picture of one tank, but in our systems, there could be multiple tanks in series, in parallel, because the storage volumes will be anywhere from a couple 100 gallons to a couple 1,000 gallons. And we are now looking at it as thermal storage, so we want many, many measurement points. Next slide. Along with the measurement points, we have the ability, last slide actually, to reach in and understand the condition of all the tanks, the full thermal storage system, and the controls. We use a product called the Skybox to reach in through our LTE network router into the Skybox. Skybox reaches into our PLC. PLC starts looking around the entire system, understanding the status, running various programs. And in our programming world, we are completely happy to get a UCM from a utility and run a utility-driven program. But we actually owe our customers some value right now, which maybe is a separate comment. And we can run additional native programs to avoid the purchase of high peak rate electricity. So we've got storage, we've got control, we've got in our systems, we've got compressors from 2 to 36 compressors in some of our systems, and we can vary all of those and give it a run, no run signal and do quite a lot. I find it very, very exciting, and I'm looking for more. And I think the next potential for us, because I have a minute and a half so I can go off on it, is grid edge. Because really we're in a multifamily building, right? And we want to be as localized in energy usage and command as possible. We have multiple compressors creating hot water. We have large storage volumes. we're working at downsizing the physical size of storage volumes, which will allow us to put more storage in, multiple compressors, different load cycles, and large storage allows us to maybe with proper building controls squeeze in our runs and our capacity building in between the demands of heating, cooling, and car charging and other kind of local needs. This is something that we can do with multiple controls and a lot of storage. So we find it really interesting, and we're looking for opportunities to work with either policy-driven or technical research to leverage that and see what we can do with it. So there, I use most of the time.
All right. Well, thank you for that introduction, Albert, and for being ahead of schedule. And so with that, we'll pass it off to our next speaker, which is Brian Brannicky with A.O. Smith.
And I can't turn my neck that far, so
Okay,
I'm going to
here, I'll
stand
make
over
space
here.
for you.
Yeah. So just a little introduction to A.O. Smith. A.O. Smith has been around for 150 years. This is our 150-year anniversary. In case you don't know about them, they make glass-lined water heaters, harvest stores, automotive frames. We've ventured out of all of those businesses, and we're concentrating now on water heating and water filtration. We've been making water heaters since about the 1930s, and we learned how to put glass on steel without the glass falling off. So I'll give you a little bit of history about A.O. Smith's grid integration. We joined the USNAP Alliance, which back in 2012, which became CTA 2045. We introduced our first grid-connected water heater using a smart port back in 2014. Turns out the connector that we picked when it became USNAP, the exact same pinout, but was incompatible. So unfortunately, being the first isn't always the best. So we had to make a grid adapter, which you'll see on the left there. That plugged into our top of our water heater and then could communicate to CTA 2045. So that was in 2015. So we've had a lot of pilots since 2015 and trying to understand how a water heater should respond to grid signals. So next slide. This is our lineup today. These are all now CTA 2045 compatible. No longer a bridge adapter. We've got a lineup from electric to heat pumps in the middle and to 120 volt heat pumps on the right. We have Wi-Fi connectability in most of them. We have a utility version that does not have Wi-Fi, API connections. You see on the bottom, we have leak sensors, shut-off valves on the top, built-in mixing valves, pretty extensive lineup. And I'll highlight one of them in particular, the 120 volt version on the next slide here. So the 120 volt version is a shared plug. So it's got 900 watt element inside. So it can be plugged into a standard outlet. Standard things apply with the heat pump technology. You need some sort of space to cool, so you can't put it in a closed environment. It has the top connections. Our first introduction to water heaters had side connections. The top allows it to exist to existing gas applications where the hot and cold come in on the top, so it's retrofittable. Most importantly, it's quiet. When our heat pumps didn't make any noise before, our water heaters didn't make any noise. Now the heat pumps were a little bit loud for people, so we redesigned the fan to make that super quiet operation. And like I said before, it has a leak detection and shut-off valve. We were hoping that this would keep them connected because we want to know when your water heater starts leaking. So you want to make sure it gets connected to Wi-Fi. But unfortunately, it's still in the basement. It's out of sight, and it doesn't always stay connected. So if you're not connected, you're not going to get that alert. So we're hopefully trying to highlight the fact that you really want your water heater to be connected to Wi-Fi at all times. And the last slide here, I'll talk a little bit about our app. So our app, we can communicate to the water heater in two ways. One, we can do demand response, and that's off to the right. We either do it through like our water saver program through virtual peaker. We can do APIs through our Wi-Fi, or we can go CTA 2045 modules for the demand response. For the time of use rates, we go through our app It's a series of pages where you pick the utility, you pick your rates, and then most importantly, you pick your user preference. And your user preference basically says what you want to do during the high price periods. When we first came out with that, we had some customers who said that they wanted the water heater to turn off during the high price periods. We thought they bought a water heater to get hot water, so we didn't have that feature. So we added yet another slider application there where they can, during high price periods, just stop the water heater from performing. With that, they get a little alert saying that if you enroll in this, you may get a cold water event. So as long as they're aware of that, we enabled that feature, and we hope it's working for those people who want that.
Okay. All right. Sure. Right. And since we didn't do that last time, let's step back in time and clap for Albert quickly.
That's right. Let's give everyone their just desserts. Thanks, everyone. Good afternoon. Christopher Freeman, Director for Credit Products at Rheem Manufacturing. A little background on Rheem. We are probably one of the few manufacturers in the U.S. and the world that do offer HVAC, water. We have refrigeration. We have pool heating. So anything that relates to heat transfer from air to water, cooling air. We don't heating water. We don't do a lot of cooling of water except up in the Middle East. But we have a really big value in that when we talk about the home as an envelope, we have a lot of components that go in there that are under that Rheem umbrella. And so the interoperability of having devices that can talk under one system is really helpful as we step into that HIMSS or that CER, or that treating that building, residential or commercial, as one envelope. So we don't always have to look at how do I get disparate systems to connect and talk to each other. I don't necessarily need a middle ground in home and residential or commercial to talk, because our products natively talk to each other over Ethernet, Econet rather. Our protocol is what we call our Intel Inside. And that can either be done wired, which, let's be honest, in a home, no one's doing that. Commercial, wired also. And that's more likely to happen via RS-45, but also wireless. So again, we have that capacity to really present, the whole home as one envelope, because we do touch so many components within that building. The next slide, please. So this is the, I'll just speak really primarily on the water heating side, a little less on HVAC. When we talk about HVAC, we all understand a little of the discomfort in there, and we could go into variable speed and how our systems that talk on our Ethernet protocol are a little more responsive to dynamic pricing, because it's never just an off and an on our system. We're using variable speed on our high end to provide a little more comfort, even doing a step down on our system, so that you never are in a off or on position on an HVAC side. On the water heating side, it's a little more complex, because as another panel mentioned, we can't just replace someone's water heater just willy-nilly. They don't do that. We can't just slap a thermostat onto the water heater and have it now be a part of our program. So we have been building out a very large portfolio of products that has, I always say, that has everything under the kitchen sink, because we kind of have to. We have to meet all the regulations, whether it's PAC Northwest with CTA 2045, California J13, Open ADR, OEM manufacturers. We have to think of this as the race for Betamax and VHS. What's going to be first? And unfortunately, we have to put everything into our products at this point around water in order to future-proof, and also to make sure that we aren't building too many SKUs, right? Because right now we're building SKUs that go directly to Washington and Oregon. We're building SKUs that go directly to California. So we have to think cognizant about what we have in the future. So our product offering, building our electronic controls, building APIs that allows for aggregators to talk to our products, and Everything that we have in our portfolio on the electric side and heat pump size is CTA 2045 compatible. Everything heat pump water heater has a CTA connection, an EcoPort connection. We do have unique SKUs on the res electric side because it's harder to burden, from a customer standpoint. Think about that customer. What does that look like? So we have different SKUs on that. But again, completing the full mix, mixing valves, shut off, leak switches, all those things are built into our products to help alleviate the pain points that are going to be coming in the future. Next slide, please, as I'm running out of time here. I want to have this slide in here to talk about a change in energy efficiency. The DOE has just announced, well, a few months ago, that on Cinco de Mayo, 2029, it's a big party, that they are changing regulations. And for the most part, most of the people that are buying resistive electric water heaters today, they won't be able to do that in 2029, Cinco de Mayo. They have to push the efficiency up. And so they are going to be forced to move to a heat pump when you think about that 30-gallon and above, which is the bulk of the market. There are still some point of use products, multifamily, that can still be res electric, but the bulk of the products that are out there in the next 5 years are going to have to switch to a heat pump technology. So we're trying to think about how do we make sure we're not creating that barrier for customers to buying the products that they need, but still giving the value for connectivity and demand response and good activity.
All right.
I'll keep this.
Yeah, sounds
I'll
good.
keep this.
All right.
Yeah.
Well, thank you very
That's
much,
fine.
Chris. All right. And our last panelist, alphabetically, you may have noticed, is Robert Benjamin from Aris Hydronics, who I will mention just last week won the DOE Easy Home Electrification or Home Decarbonization Prize. So congratulations, Robert.
Thank you. And I did want to mention that LBNL was a big part of our team, and we did research, and one of our researchers, Wei Ping, is in the audience right now, who helped us do modeling on our new system. So you'll see that I actually have some renderings here, and Aris is a little smaller than Rheem and hasn't been around as long as A.O. Smith. So we are developing new systems, and one of the things that we're heading towards is the idea that what we want to offer is thermal as a service, that all the thermal energy that goes into a building, whether that's single family or multifamily or even light commercial, that we want to be in charge of, and that we're going to think about all of those needs. And since we centralize the production of energy and distribute it through hydronics, so we're an end-to-end integrated system, we're taking care of heating, cooling, and hot water. So there's lots of areas where we can dynamically address how energy is produced and how it's used, especially when we go on to the multifamily. So next slide. So this is just kind of a diagram showing what the Aris system looks like on a single family level. And so we're using air to water heat pumps, various sizes, so depending on the capacity you need. And we're modularizing the key components, which has a tank that can do heating and cooling, and we have a dedicated tank for domestic hot water. And then a lot of the other components we're pre-building. And so it's a sort of system that can land, and we know how it's going to work in different environments, and then we customize the distribution of energy. So next slide. So this is had a lot to do with the easy submission, where we took that approach and figured out a way that we could scale this up to multifamily. It's a modular approach, so we still have a pre-built module that will, let's say, cover from 6 to 12 units, depending on the heating and cooling load. But to cover the building, we introduced more modules. This is a specific sort of diagram of a way it would be done on, let's say, a brownstone, where you put it up top. But we have another version for garden walk-ups and stuff like that. But where it gets really sort of amazing, and where we think this is now a grid asset, is that we can control all of the building's thermal energy, and we have a lot of different places that we can store that energy. So we think there's going to be some big opportunities there. All of our systems, we're kind of taking this right now, that since we are coming in behind some people, we're kind of seeing how this is going to play out. In the end of the day, we're going to have a central command and control box. We have a lot of control and algorithms that we have to do on our side to manage that production of energy and distribution of energy. So we're open to working with, I think, in the end, aggregators or third parties. So we want to work with someone who's really going to specialize on the demand side. So I think that's it for my slides.
All right, great. Well, thank you, Robert. Okay, and before we move on to questions for the panelists, one quick announcement. somebody did leave an iPhone up here. So all right, I'll hold on to it for you, Bruce. All right. Well, that was quick. Okay. So the first question that I had for all of you today was, how are OEMs adapting their product strategies to meet the growing demand for smart energy solutions?
Yeah,
Anybody?
sure. Yeah, I'll jump in. I think I hit on this a little bit earlier. We are looking at the right components, the right technology to go into all of our products. As we have pressures, from DOE, from regulation, when someone goes into a Home Depot or a Lowe's to go buy, a water heater, most of the times they don't do a lot of thought process to think about what they're buying. So they're buying, hey, the first thing, emergency to get out there. So we had to think about a way to pull out that thought process from that person's, mindset. Do I want to buy a connected water heater? Well, if we have the ability to remove that as an option, well, if everything had the ability to connect, then there's really not that decision point. I'm just really going on price, this one compared to that one. And right now, people have a choice. I can choose to not buy a Wi-Fi enabled water heater, a CTA 2045 water heater. Well, except for Washington, Oregon, they have no choice. But the bulk of the US, they have an option to buy something that they don't have. And it's our job to say, how can we manufacture products better at a lower cost to put more stuff in them that don't impact that business owner, that homeowner in the future?
Well, thank you. Okay, I think we're on. Great. So we're in a situation where we're working with larger loads, larger buildings, and we're working with engineers, maybe a fresh project, or it could be a retrofit project. We find right now we're listening to our clients and we're listening to the market, and we're listening to policy and regulation, but there's a bit of a gap. And the gap is really an opportunity for us. We're all preparing. I'm from Washington State, right? So everything has a CTA 2045 and kind of these residential products. And in the larger systems, they're just coming on. So right now we're building in all that capacity, and in order to build and make use of that capacity, we're building extra storage. So we actually have infrastructure, and what we're trying to do right now is find value to the customer. So like maybe an A.O. Smith app product, we can scale that up, develop some native operation programs to kind of operate and mimic the effect of a load shed command from a utility, and just reduce the amount of peak rate energy purchased. So it's opportunities like that that we're trying to build into the systems, and right now we're eager to hear more from policy and more from customers. These are large systems, and the capacity of grid flexibility is really quite hefty and useful. So
Yeah, the technology that we're trying to put in, like I mentioned in the slide before, we have demand response and we have time of use. And demand response, when it first came out, it all had to do with meeting customers' expectations. So we erred on the side of making sure that hot water was going to be available to them. What the utilities wanted to see a deeper amount of shed. So we're balancing between the two of them. So as part of the CTA standard, we have this idea of a user participation level, where he could, maybe enroll a little bit further, get a little bit more deeper in his shed at the risk of running out of hot water. But the utilities really didn't have a mechanism for incentivizing them to actually turn that signal on. So we have this technology, but we're trying to balance, the consumer and the utilities. When it came to time of use, the time of use rates were a little bit more transparent. So we noticed that some users, when they have time of use, just simply avoided using their water heater during that period. So it didn't really matter if we sent them a shed signal or not. The water heater was never going to be turned on anyway. So they knew in advance and changed their behavior because of that. So the technology is there, but how it operates and how it's used, we're still learning about it.
I'll defer to the next questions. Those were good answers. So,
All right, fair enough. Sure.
These, there's a lot going on here, right? There's a lot to keep up with. So one of the things in a larger application, there's a significant amount of money to be saved by not buying peak energy, right? So how do you express that to the client? Fortunately, some of our partner organizations, Ecotope in Seattle, received some funding to build out a utility price calculator. So they can actually present to us what the algorithm is, what the load profile of the water heater in this 100-unit multifamily building or something like that. We can overlay that onto our heat pump run cycle. We can understand how many kilowatt hours are going to go in across ambient temperatures, right? So we've got a really fine detail of what that energy profile, and now we actually have a calculator, a cost calculator that we can overlay the peak and off-peak energy prices and present the client with savings. The client can choose, much like an app, whether to operate on that program or operate on the very simplistic 40% aquastat fraction program, run, no run. The initial savings that we're finding are anywhere from $1,200 to $2,000 a year in energy saving, depending on what market you're buying in. And that's a value that we can present to the customer right now. So.
Okay, great. Well, thank you for those comments, everybody. So next question is about the location of the intelligence, right? As we look at time of use rates or highly dynamic prices, we have a lot of conversation around whether or not the intelligence to respond to the prices is right on the manufacturer's product or somewhere in the cloud, which then sends signals out to the products. And so we'd really like to hear your thoughts on, should your products have the intelligence right on board, or should your products have communication capabilities so that a grid operator could host their intelligence and send the signals?
Yes.
Okay.
I think the not simple answer is that there can be a happy medium. Some onboard algorithms and logic to receive commands, store commands, and know how to interact more in the local network for that building envelope of what's happening to respond to what's happening. But also, I do think it's important because the actual pressures on the grid are not static. They are dynamic. And so there is still a need for, if something needs to be different, time of use and put them in there, and they're in there for the next, few weeks, few seasons, few years, and they don't change unless you go in there and physically change it. Having that ability on top of having a dynamic receipt of a signal, I think is the best of both worlds. So there's a little bit of edge and a little bit of cloud that in a real world deployment, I think gives you the best of the best solution.
So our system, we already have to do a ton on the on the building side. Anyway, and the way that I look at this is that we're already optimizing for a lot of things. So we're going to be looking at the load, we're going to be looking at efficiency, we're looking at comfort, looking at a way to balance the energy production against the use. But I think there's two sides of this. There are suggestions that will come from the grid. And I think, again, looking them as we're looking out for our occupants, first and foremost, that we want to take those as suggestions and then figure out how to implement them in the best way. But there's the other side, which is, I think we're missing that all these systems, one of the big additives is that there's data there that we also can be passing back and forth. And it's a level of accountability that I think people aren't recognizing is also the big additive to this. How are these systems running? How much energy are they using? Are they delivering what they're supposed to be delivering? And I think for us, that even if we didn't take that demand signal for verbatim of what it said, we would also be able to provide the data to show that we're actually accomplishing that goal in maybe a different way.
So we have either or. You can have it on the water heater itself, or it can be external to the water heater. Maybe that might be on the edge, might be in the cloud. Our biggest challenge, I think, is that when there is a cold water event, they're likely to call the manufacturer on the side of the water heater. And when that happens, the first thing we're probably going to ask is, who's in control? So if we're not in control, there's not much we can do about it. If we know we are in control, then we can improve our algorithms. We can do a better job. We know how to manage the thermal energy. So it becomes a question of support, really, and who's going to field those questions. Because if it's not us and it is external, we don't even know who to point the finger to. Who are they supposed to call? So it's a little bit of a challenge from that standpoint.
I think we would prefer to receive all pricing information from the utility in a single source through an open ADR platform. I think for our systems, larger systems, we prefer to operate that way. We have less risk. Our loads are spread over many, many occupants, so we have less cold water event risks. And I think if pricing is available coming in, then I think our operational program will be largely load shed and really grid informed. Thanks.
All right. Okay, well, thank you for those responses. And I've got one more question that I wanted to ask before we open it up to questions from the audience. So load flexibility is getting a lot of attention from the research community, regulatory bodies, and I'm sure from several of your customers at this point. And so I'm wondering, as you balance, making sure you meet the customer's expectations and the pressures to implement load flexibility, and as you're developing new products to balance those two different expectations, what sorts of collaboration or support from research organizations and regulatory bodies would help you accomplish that?
Well, grid flexibility is largely driven by a quantity of storage available. And one of the big questions is how much storage is enough? And does the storage need to be designed into a larger system as flexible storage? How much can we leverage the existing storage? I don't think we fully understand that right now. And we're kind of in this position where, okay, we're going to go into grid flexibility. We're going to size a brand new building right from a clean piece of paper. We can run some tech in California. We can run a tech analysis. It can inform what the sizing is based on some sizing norms that are still a bit young. So spending a systems operating on flexible profile that were sized for additional storage and not sized for additional storage would be really interesting, especially those not sized for additional storage in larger systems, because my posit is the storage is there. We can probably get really close to some pretty good flexibility or shedding. We just don't know yet because we haven't measured it.
Yeah, I think the problem gets a little bit worse on the residential side, because when a homeowner goes to buy a new water heater, is he going to buy one with a built-in mixing valve? Does he need that extra storage to ride through the evening peaks? He may not necessarily know that. Maybe he's going to change his behavior a little bit. Maybe he could have changed his behavior a lot and saved some money and not bought that. These are all decisions that, frankly, I don't think he has the capability of making, because he doesn't even know probably when his hot water heater does turn on. So I think we need a little bit more, maybe pilot programs, a little bit more simulation to find out, when are the consumers doing it? What kind of questions do they need to be asked when they go to purchase a new water heater?
Brian, could you take a quick moment to point out what a mixing valve is and why
Oh,
somebody
yeah,
would
yeah,
want
yeah.
or
So,
not want one?
So we have some built-in mixing valves now. Our water heaters will work without them if you add the mixing valve. But what that allows you to do is send a demand response that increases the set point temperature of the water heaters so that the user sees their set point. So now you can store even more hot water with a lower volume. So that mixing valve allows us to have more thermal energy to shift. And if it's a built-in mixing valve, then it's even simpler to implement.
I think yeah, a lot more sort of research and data would be nice. But one of the things that I think is at the back of this is, for me at least, I understand a lot of additive benefits that you can give the building owner and the occupant and that side. But what I'm sort of struggling with is on the utility side and the different ways that they make money and the way they have to invest. How are we making this connection so the incentives come together? And I guess that has to be somewhat regulatory, but I'm also just wondering, I mean, again, is it taking their excess energy and storing it when we can store it, like you said, when we can jack up the temperature of the tanks and stuff like that? How do they recognize that as a value? And then how does it translate into where they're investing? Anyway, I think there's just this big chasm between the two right now that isn't going to be solved without this kind of working group that is happening. So.
Okay. Anything, Chris? All right. Well, in that case, I'd like to open it up to questions from the audience. So Scott, do we have any online?
I do. We have two.
Okay.
The first one is related to adoption in new construction. Are heat pump water heaters or smart water heaters with additional thermal storage becoming the default choice in new construction, or are builders still seeking out the most cost-effective option and technology agnostic?
Definitely depends on the builder, where they are. There are some more advanced builders who are looking for ways to put in higher efficiency products. Even builders that are using IRA dollars and rebate dollars to buy heat pump water heaters, install them, and then pass that along to the end customer. So it really is dependent upon who that builder is. I will say that a majority of builders, 90% of them, they're still in that realm of, okay, what's my total cost to build and turn over the keys? I can get out of there. That happens from a builder standpoint. A little bit different when you think about multifamily, as there are more multifamily builders that are saying, "Hey, I own the building. I'm going to keep the keys in my pocket." So I do care about what the efficiency is. I do care about what programs they are in. So I think it's on a case by case basis, but for the most part, builders are still trying to get the lowest cost options to get in and get out.
Okay, great. The final online question speaks to the motivation of original equipment manufacturers to develop these new technologies. Is it consumer preference, appliance distributors expressing an interest, creation of a new market opportunity for managed thermal demand, or is it primarily driven by regulation?
For our company, it's market opportunity and anticipating regulation, which really is back to opportunity.
Yeah.
All right. Well, that was quick. And I noticed that Teresa had a question earlier. So could somebody get her a microphone? Kula's on it.
Hi, Therese Peffer from UC Berkeley. Can you respond to, as devices become more and more Wi-Fi enabled, what happens when someone doesn't have Wi-Fi and they want to connect to the internet and they want they want to interact with load flexibility? And what happens when the tenant leaves or the home changes hands and that Wi-Fi leaves? What is the plan for that transition? Thank you.
Yeah, so Wi-Fi as an equitable option is the question. Not everyone has Wi-Fi. People are beginning to look at, what can we do with multifamilies? Hey, we want to put in our own Wi-Fi network to support smart devices. If you look back at our slide, and I think, even Brian had a slide, I mentioned as OEMs, we are putting in as much technology as we need to help, circumvent all of this technology question. Hey, I don't have Wi-Fi. Well, do you do cellular? Well, who pays for this cellular? Well, how do you get a UCM? Does UCM come out of the ethosphere, or does a utility provide that? So those are questions that we're trying to answer from an equitable standpoint across. And it's not an OEM. I don't think that it is not an OEM only question we asked of how do you support that, because we are willing to put in all the technology that's needed. But then again, how do you extract that and leverage that? And then to the point of what happens when someone leaves, well, that now becomes a drop in the bucket of a potential loss. That person that had Wi-Fi and had it connected, for whatever reason they connected it, they understood the value to get it connected and then be a part of a program. That next person in that house or that building, they may not know. And then how do we as OEMs, as an industry, communicate to that person, hey, you bought a brand new house and it has all this great stuff that can add value. How do you make that connection to communicate to them? Because the other home is lost. We've had permissions to communicate with that. And in theory, when they leave, their Wi-Fi SSID leaves, so that device is now lost, and it stays lost until that next homeowner miraculously says, hey, I'm going to connect my water heater for some reason, and then be a part of a demand response program. So it becomes very, very hard as you stack up, especially when it's a secondhand device in a home that I purchased versus one that I bought myself.
Yeah, so when we first was developing a connected water heater with the USNAP Alliance, we realized that we didn't want to build every different type of version. When Chris was talking about all the different SKUs that are out there. So we jumped on any kind of standard where we could just build water heaters. So through the CTA 2045, now you can have a cellular module, Zigbee, it doesn't matter what communication protocol. And so that doesn't really burden us on the OEM manufacturer. So now, if you want to enroll in a different program because it's a new user, you simply put in a new CTA 2045 module. So that kind of takes the burden off of us. If it is Wi-Fi connected and it's our Wi-Fi connection, yeah, now we're talking about a different story. But hopefully with this, it could be a cellular. And, maybe 5 years down the road, there's a new technology that everybody's jumping on. And the water, it could be whatever. And the water heater, it's going to last 10, 15, 20 years. It doesn't have to be replaced with that. So.
Yeah, I just think that it's important to identify what needs to be universal and then get government and industry and, people behind that, because other people are going to be left behind. But I think one thing is missing from this conversation is that there is contractor support. There are things that need to be left behind as we change to be more complicated systems. The education that goes along with the things are going to change, right? So we just going to have to identify that. But it seems like some of the app approaches, as long as you can bring the data costs down, which I think you can, there's a way to keep connectivity as long as they know it should be right on there how to do it when the new owner takes over. But
so for us, higher value assets, so we do build in and provide a LTE SIM card through a network router. And we've done that after studies in, Texas or South. Utilities in the South Central did some studies and lost 60% of their Wi-Fi connectivity on some of their units. And we wanted to stay out of that because connection to the unit is really important for us for a number of reasons. But it's really interesting because there's a lot more we can do, and it's creating a little more innovation on our side. So one water heater has got an LTE signal and it's got a network router, and we can see it, and that's great. But we're in Southern California, we're doing a new round of retrofits, 14 kind of smaller walk-up buildings that are all getting retrofitted. Out goes the gas, in goes the heat pump water heater. And so we don't really, and it's a single building owner. And so we're taking 14 buildings, cutting them in half, one central plant with a few hundred gallons of water for each of those pairs of buildings. Now we would be looking at 7 plants with 7 SIM cards, which seems a little onerous for a low-income housing property owner. So now we've built out another controller with LTE in, router switch or network router, additional switches in the control with a Wi-Fi module that we have one connection to the cloud and then a Wi-Fi connection on our own network that doesn't touch the building to the other 6 plants or 7 plants within the building. Each plant has a skybox, so each plant is recognized by anybody entering through the cloud as a unique water heating plant and can operate whatever programs we want to operate. So it's kind of like a mixed right? With a higher asset value, we feel like the value we need to bring is 100% connection, no matter who's around doing what, whenever. And then reducing costs by finding new innovative ways to spread that single system out within, you know, a block or two of that single installation.
Okay. All right. And we're at time for today. So as much as I'm sure we'd like to continue the conversation, we should leave time for you to make it to the next session. So let's thank all of our presenters for sharing their thoughts today.